Module 8, Software Testing. Let's take a look at the table of contents for this section 01, Introduction and Basic Concepts 02, Stage and Type of Software Testing 03, Life Cycle and Process of Software Testing 04, Unit Test and Component Test 05, System Test and Integration Test 06, Test Drive Development TDD 07, Release Tests and Acceptance Tests 08, Static Verification and Code Checking 09, Debugging and Defect Management 10, Future Trends and Summary Part 01, Introduction and Basic Concepts. The importance of the software testing. Definition of the software testing. Software testing is a key link in the software development lifecycle, aiming to verify the function, performance, and reliability of the software, find defects, and ensure the software quality. Goals for the software testing. The goal of software testing is to provide stakeholder confidence, ensure that the software works as expected, and identify potential problems at early stages to reduce later repair costs. The difference between validation and validation. Validation of the validation verification is the process of ensuring that the software product meets its specifications. It focuses on whether the product is built correctly according to the design and requirement specifications. Validation. Validation is the process of ensuring that the software product meets the user needs and business objectives. It focuses on whether the product solves the user's practical problems and is valuable to the user. Test the objectives and principles. Test object. Test objectives include validation targets and defect targets. The verification objective is to test and verify that the software meets the requirements of the requirements document, while the defect objective is to identify the software as being wrong, unstable, or not meeting the requirements. The test principles include that the test should be performed systematically and that the test cases should fully cover all function points and include records of the expected and actual results. Part 02, Stage and Type of Software Testing. Overview of the test phase. Develop the test phase. The development testing phase includes unit testing, component testing, and system testing. The unit test focuses on the correctness of a single module or function, while the component test focuses on the interaction between function and interface after the combination of multiple units, and the system test evaluates the function and performance of the whole software system. Release the test phase. The release test phase ensures that the software is ready for release to the end users. It is performed by an independent testing team with the focus on ensuring that the system meets the publishing criteria. The user testing phase. The user testing phase is conducted in the user environment to assess the actual usage of the software. It includes alpha tests and beta tests, as well as user acceptance tests, UAT. Test type classification, function testing. Functional tests verify that the software functions meet the requirements. It includes user interface, API, database, security features, and more. Non-functional tests. Non-functional testing focuses on the performance, reliability, usability, scalability, and security of the software. It ensures that the software meets standards related to overall performance and user experience. Detailed test type, system testing. System testing is an overall evaluation of the entire software system. It is designed to verify that the integrated components work together as expected and meet the specified requirements. Acceptance test is the final test phase before the software is delivered to the user to verify that the software meets the user's needs and business objectives. It is usually performed by the user or by the customer. Detail test type unit test. Unit testing is the initial stage of software testing, focusing on individual components or modules in the test software. The purpose of unit testing is to ensure that each unit performs its function as intended. Integration testing. Integration testing builds on unit testing, examines interactions between integration components, and discovers issues associated with their interfaces and collaboration. Part 03, life cycle and process of software testing. Software testing, life cycle, STLC, demand analysis stage. During the requirements analysis phase, the test team worked with the project stakeholders to understand the software requirements and objectives. This includes identifying functional requirements, performance metrics, safety requirements, and defining the test scope and objectives. Test plan phase. The test planning phase involves the development of test strategies, resource allocation, schedules, and test deliverables. The test plan shall include the test objectives, test methods, test environment, test data, and the risk management plan. Test design phase. The test design phase includes the design of test cases, preparing test data, and test scripts. The test case shall cover all functional points and include records of the expected and actual results. Software testing lifecycle, STLC, test execution stage. The test execution phase is the process of running the test case and recording the results. Testers need to perform test cases, record the actual performance of the software, and compare with the expected results. Defect reporting and repair stage. During the defect reporting and repair phase, the tester records the discovered defects and works with the development team to ensure that the defects are repaired in a timely manner. Defect tracking is a key activity at this stage. Test summary and shutdown phase. The test summary and closing phase involves analyzing test results, generating test reports, and evaluating the test process. This includes assessing test coverage, defect density, and test efficiency, test methods, and techniques. Black box testing. Black box tests focus on input and output, regardless of code internal logic. It is suitable to test whether the functions of the software meets user needs and business objectives. White box testing, white box test analysis code structure, test code paths, and conditions. It works for internal logic and code coverage of the test software. Test methods and techniques, gray box testing. The gray box test combines the advantages of the black box test and the white box tests, considering both the internal logic of the software and the external functional performance. Equivalence partitioning. Equivalent class division is a test design technique which divides the input data into several equivalence classes. And the data in each equivalence class should have the same test behavior. Test methods and techniques. Boundary value analysis. Boundary value analysis is a test design technique that focuses on testing boundary conditions for the input data because errors tend to occur near the boundary. Decision table test. Decision table test is suitable for testing software with complex logic and multiple conditions. It represents the different combinations of input conditions and their corresponding outputs by creating a decision table. Test methods and techniques. Status conversion test. State transition testing is suitable for testing software with multiple states and state transitions. It verifies that the software acts as expected by simulating state transitions. Path test. P-way testing is a test strategy designed to run each independent execution path in the software. It ensures that each statement is executed at least once and evaluates the true or false results of the conditional statement. Part 04. Unit test and component tests. Definition and purpose of the unit test 1. Definition of the unit tests. Unit testing is the minimum unit of software testing, focusing on a single component or module in the test software. The purpose is to ensure that each independent code unit performs its function as intended and is an early stage in detecting and fixing code defects. 2. Purpose of the unit testing. The purpose of unit testing is to verify that the minimum testable unit in the software performs its functions as designed. It helps developers spot and fix defects at the code level, thereby improving the overall quality and reliability of the software. Definition and purpose of the component testing. Definition of the component test. Component testing is testing for independently testable units in the software that are often a module or a set of closely related functions. It ensures that each component performs its function as expected and interacts correctly with the other components. Purpose of the component testing. The main purpose of component testing is to detect defects within the components in the early stages of software development, thereby reducing the problems in the later integration and system testing stages. It helps to verify the component interfaces, data processing, and business logic. Comparison of the unit test and the component test scope and objectives. The unit test focuses on the correctness of a single module or function, while the component test focuses on the function interaction with the interface after the combination of multiple units. Unit tests have smaller scope and are more focused on the details of the code, while component tests focus more on intercomponent interactions and overall functionality. Test methods and tools. Unit testing often uses automated testing frameworks such as JUnit or TestNG to write and execute test cases. Component testing may require more complex test settings, including simulated interactions and dependencies. Comparison of the unit test and the component test. The complexity of the test unit tests are generally simpler because they focus on a single code unit. Component testing may be more complex because they need to handle interactions and dependencies between multiple units. The timing of the test unit testing is often performed early in the development process to enable continuous integration and continuous delivery. Component testing may be conducted after multiple units are developed and integrated to ensure correct interaction between components. Part 05. System test and integration test. Definition and purpose of the system test. Definition of the system testing. System testing is the process of conducting the overall evaluation of the entire software system. It includes testing of all the functional and non-functional requirements of the software, ensuring that the software as a whole is able to meet the needs of the users and the business. Purpose of the system testing. The purpose of system testing is to verify that the entire system meets its specifications and is to correctly interact with other system components. It ensures that the software system behaves as expected and operates stably in a variety of environments and conditions. Definition and purpose of the integration test. Definition of the integration testing. Integration testing is the process of examining the interaction and data flow when different modules or components are grouped together. It ensures that components work correctly and identifies interface and integration issues. Purpose of the integration testing. The purpose of integration testing is to discover and fix possible problems during component integration, including interface errors, data loss, and timing issues. It ensures that the software components can work correctly as a whole after integration. Comparison of system tests and integration test range and depth. The system testing covers all functional and non-functional requirements of the software. Integration testing is more focused on intercomponent interactions and data flow, test objectives and priorities. The goal of system testing is to validate the function and performance of the entire system, while the focus of integration testing is to ensure correct integration and data consistency between components. Comparison of system test and integration test 1. Test methods and tools. System testing may use more complex test scenarios and tools, including performance test tools and safety test tools. Integration testing may rely more on test frameworks and tools that simulate interactions between components. 2. Test timing and stage system testing is usually performed after the integration of all components, while integration testing is gradual during the component integration process. System testing is one of the final stages in the software development cycle, and integration testing is a continuous activity in the development process. Part 06. Test drive development TDD process and advantages of TDD. The process of TDD processes include writing test cases, performing tests and verifying failures, writing code through tests, refactoring code, and ensuring that tests pass. This cycle repeats until the function is complete. Advantages of TDD can detect defects in advance and reduce the cost of later repair. It also facilitates the modularity and testability of the code, thereby improving the overall quality of the software. In addition, TDD helps improve the quality of testing with continuous regression testing, ensuring that software changes do not introduce new defects. Application of TDD in Agile Development 1. A combination of Agile development with TDD. Agile development emphasizes rapid iteration and continuous delivery, and TDD naturally fits with Agile development. TDD enables short cycle iterations and frequent delivery in Agile development. 2. TDD practice in Agile teams. In Agile teams, TDD is often used as part of the daily development activities. Team members need to collaborate to write test cases and continuously improve code and testing in each iteration. Free impact of TDD on Agile delivery. The impact of TDD on Agile delivery is reflected in its ability to improve the delivery speed and quality of software. Through continuous testing and refactoring, TDD helps the team respond quickly to changes and consistently deliver high-quality software products. Part 07, Release Tests and Acceptance Tests. The definition and purpose of the publishing test. Definition of the release test. Release testing is a stage in the software development cycle that ensures that the software is ready to release to the end users. This phase is performed by an independent testing team with a focus on ensuring that the system meets the release criteria. The purpose of the test. The purpose of the release testing is to verify that the software is suitable for release. It includes a series of testing activities designed to discover and fix undiscovered problems during the software development process, ensuring that the software meets the desired quality standards before being delivered to the user. Definition and purpose of the acceptance test. 1. Definition of the acceptance test. Acceptance testing is the process by which users assess whether the software is suitable for deployment and use. It is usually performed by the end user or customer to verify that the software meets business needs and user expectations. 2. Purpose of the acceptance test. The purpose of acceptance testing is to ensure that the software meets the user's needs and business objectives. It helps users confirm whether the software can solve practical problems and provide confidence in the final delivery and deployment. Release test versus acceptance test initiator and purpose of the testing. Release testing is usually performed by an independent test team outside of the development team to ensure that the software meets the release standards. Acceptance testing is performed by the end user or customer to verify that the software meets the business requirements. Range and depth of the test. Release testing focuses more on the overall quality and stability of the software, including performance testing, safety testing, etc. Acceptance testing focuses on whether the software meets specific business needs and user expectations. Execution and results of the testing. The results of the release tests are often used to determine whether the software can be released. The results of the acceptance test are used to determine whether the software is accepted by the user and can enter the production environment. Part 08, Static Verification and Code Checking, Static Analysis Tools and Advantages. Definition of a static analysis tool. Static analysis tools are software tools used to analyze the source code without actually executing a program. They are able to detect bugs, code vulnerabilities, code style issues, and potential performance issues. Advantages of the static analysis tools. Static analysis tools are able to detect potential defects without running code, saving test time, and improving software quality. They can also help developers follow coding standards and improve the readability and maintainability of the code. Code checking process with benefits. 1. The process of code checking. Code checking is a static verification method that involves manually reviewing code to detect errors and non-conforming practices. The inspection process usually includes reviewing the logic of the code, its structure, naming conventions, and comments. 2. Benefits of code checking. Code checking helps to detect errors in advance and reduce the complexity of later debugging. It also facilitates knowledge sharing and dissemination of best practices among team members, helping to raise awareness of code quality across the team. Part 09, Debugging and Defect Management. Introduction to the debugging process. Definition of debugging. Debugging is the process of identifying and fixing code errors during software development. It usually occurs after the test phase finds defects, and developers need to analyze the test results and code to locate the problem. Debugging steps. The debugging process includes reproducing the problem, locating the source of the problem, analyzing the cause of the problem, repairing the problem, and verifying the repair. During debugging, developers may need to use debugging tools to step-by-step code, observe variable values, and program processes to determine the specific location of the problem. The challenge of debugging challenges facing debugging include understanding complex code logic, handling intermittent errors that are difficult to reproduce, and finding the root cause of the problem in a limited time. Effective debugging requires patience, careful observation, and a deep understanding of the system behavior. Methods and practices of defect management. Defect tracking system. Defect tracking system is used to record, classify, and manage defects discovered during software development. These systems often include information about a detailed description of defects, discovery time, status, priority, and repair progress. Defect reporting and communication. Defect reporting shall detail the defect discovery process, reproduction steps, scope of impact, and possible solutions. Effective communication is key to defect management, ensuring shared development team and stakeholders. Methods and practices of defect management, defect repair, and validation. After the defect is repaired, the relevant test cases need to be re-executed to verify that the defect has been successfully repaired. The validation process may include regression testing to ensure that the repair does not introduce new defects. Defect prevention measures. Defects can be prevented by methods such as code review, static analysis, and test-driven development. In addition, continuous training and knowledge sharing can also help to improve the team's defect prevention capabilities. Part 010, Future Trends and Summary, Future Trends in Software Testing. Artificial intelligence-driven automated testing. Artificial intelligence AI. Technology is changing the field of software testing, especially in automated testing. The AI can analyze test data, identify patterns, and predict potential flaws, thereby improving test efficiency and accuracy. AI-driven test tools can automatically generate test cases, optimize the test process, and provide intelligent defect analysis. Continuous integration and testing, CI/CD, continuous integration and continuous deployment, CI/CD, has become a standard part of modern software development practices. Testing plays a key role in the CI/CD process, ensuring that every code submission is rigorously tested to quickly detect and fix defects and accelerate software delivery. Future trends in software testing. Test as a service, TaaS. Test as a service, TaaS, is an emerging software testing model that allows companies to outsource testing work to professional test service providers. TaaS can provide flexible testing resources, reduce testing costs, and leverage the knowledge and experience of the professional team. Summary and prospect of the software testing objectives and process of software testing. The goal of software testing is to ensure the quality and reliability of software products and to provide stakeholder confidence. The testing process includes requirements, analysis, test plan, test design, test execution, defect reporting and repair, and test summary and shutdown. Systematic process from unit testing to system testing. Software testing covers multiple stages from unit testing to system testing, each with its specific goals and methods. Unit testing focuses on a single component. Component testing focuses on the combination of multiple units. System testing evaluates the behavior of the entire application. And acceptance testing ensures that the software meets business requirements. Summary and prospect of the software testing. Advantages and tool support for test-driven development. TDD, test-driven development, TDD, is a development method that requires tests to be written before code. Advantages of TDD include improved code coverage, support for regression testing, and simplifying the debugging process. The practice of TDD requires appropriate tool support, such as an automated testing framework and continuous integration tools, continuous improvement and optimization of the software testing. Software testing is an evolving field, and as technology advances and market demands change, testing methods and tools are constantly evolving. In order to remain competitive, test teams need to constantly learn and apply new testing techniques and methods, and continuously improve testing processes and practices. Thanks.